Overfitting versus underfitting in AI. Overfitting versus underfitting in AI. Beginner level. Introduction. Artificial intelligence. AI. Models learn patterns from training data to make predictions. However, sometimes models learn the data too well or not well enough. These situations are called overfitting, underfitting. Both problems affect the accuracy and reliability of machine learning models. Understanding overfitting and underfitting helps developers build better AI models that perform well on new data. What is overfitting? Overfitting occurs when an AI model learns the training data too closely, including noise and small details that do not represent the real pattern. In simple words, overfitting equals the model memorizes the training data instead of learning general patterns. Example concept. Training data means model memorization means poor performance on new data. When this happens, the model performs very well on training data but poorly on unseen data. Example of overfitting. Imagine a model trained to predict exam results. Training dataset. Study hours result. 2 fail, 4 pass, 6 pass. If the model memorizes these examples exactly, it may struggle when encountering new values. Example concept. Training examples memorized means incorrect prediction for new data. This means the model does not generalize well. Signs of overfitting. Common indicators of overfitting include very high training accuracy, poor testing accuracy, complex models with too many parameters, model memorizing noise in the dataset. Example concept. Training accuracy high means testing accuracy low. What is underfitting? Underfitting occurs when a model is too simple to capture patterns in the data. In simple words, underfitting equals the model fails to learn the underlying pattern. Example concept. Dataset means simple model means poor predictions. Underfitting results in poor performance on both training and testing data. Example of underfitting. Consider predicting exam scores using study hours. Dataset. Study hours score 240, 460, 680. If the model ignores the relationship between hours and scores, it cannot learn the pattern. Example concept. Insufficient learning means inaccurate predictions. Signs of underfitting. Indicators of underfitting include low training accuracy, low testing accuracy, overly simple models, failure to capture patterns in data. Example concept. Training accuracy low means testing accuracy low. Overfitting versus underfitting comparison. Concept description. Overfitting model learns training data too closely. Underfitting model fails to learn patterns in data. Training accuracy high in overfitting, low in underfitting. Testing accuracy low in both cases. A good AI model should balance between these two extremes. Ideal model behavior. The goal of machine learning is to create a model that generalizes well to new data. Example concept. Training data means learned pattern means accurate predictions on new data. Such models capture true patterns rather than memorizing or ignoring data. How to reduce overfitting. Several techniques help reduce overfitting. More training data. Larger datasets help models learn general patterns. Simplifying the model. Reducing model complexity can prevent memorization. Regularization. Regularization techniques penalize overly complex models. Cross-validation. Using cross-validation ensures the model is tested on different data subsets. Example concept. Training data means validation means improved generalization. How to reduce underfitting. Underfitting can be improved by using a more complex model, adding more features, increasing training time, adjusting model parameters. Example concept. More learning capacity means better pattern recognition. Example Python concept. Example idea using machine learning libraries. From sklearn. Linear_model import linear regression. Machine learning libraries allow developers to adjust model complexity to avoid overfitting and underfitting. Real-world examples. Image recognition. An overfitted model might memorize training images but fail to recognize new images. Financial predictions. Underfitting models may fail to capture trends in financial data. Recommendation systems. Balanced models help recommend products accurately without memorizing user behavior. Concepts learned from overfitting versus underfitting. Understanding these concepts helps beginners learn. Checkmark how machine learning models learn patterns. Checkmark why dataset splitting is important. Checkmark how to improve model performance. These ideas are fundamental in machine learning and AI model development. Simple definitions. Overfitting. When an AI model memorizes training data and performs poorly on new data. Underfitting. When an AI model is too simple to capture patterns in the data. Final summary. Overfitting and underfitting are common challenges in machine learning. Overfitting occurs when a model learns training data too closely, while underfitting occurs when a model fails to learn patterns in the data. The goal of machine learning is to create models that generalize well to new data. Techniques such as increasing training data, simplifying models, and using validation methods help balance model performance. Understanding these concepts is essential for anyone studying artificial intelligence, machine learning, and data science.